All right, we're going to resume here, page 275, example 3, evaluating trig functions of 30 degrees and 60. We've gone over the 45, 90. We're going to look at 30, 60 now. It says, using the equilateral triangle shown here, find the exact values of sine 60, cosine 60, sine 30, cosine 30. So we know in any equilateral triangle, we drop that altitude down. Each of those angles must be 60 degrees. 60 times 3, 180. So we know we have a 60 here, a 30 here. And thinking back to your geometry and your ratios of sides, we see, again, the smallest side length in a 30, 60, 90 is 1. The largest value is 2. And the medium value, the square root of 3. So we're going to be looking at this as though this 60-degree angle at first were theta. So we're going to talk about the sine of theta, opposite. The sine of theta being 60 degrees is equal to opposite over hypotenuse. The cosine of 60, adjacent over hypotenuse. And then they wanted us to assess from the other end of things here, from 30, the sine of 30 degrees, the sine of 30, opposite over hypotenuse, and the cosine of 30 is equal to adjacent over hypotenuse. Let's go ahead and look at problem number 23 and come back here and we'll look at our solutions. Well, 23 is asking us the same thing as 21. It says construct the appropriate triangle. We're dealing with that 30, 60, 90 again. So, but this time we have the radians. We have pi over 3 radians. And we know we're going to multiply by that unit conversion factor. We know that 180 degrees is equivalent to pi, which is equal to 1. We're multiplying our radians by 1. We see pi cancels. 180 divided by 3 gives us the 60 degrees that we're looking for that first value. Well, these are both not very good looking angles. If we see we have 60 degrees in that corner, we know 30 degrees down here. And the tangent, the trig function tangent, is defined as the opposite over the adjacent. So coming from this angle theta, 60 degrees, the opposite over the adjacent. So let's go back over those ratios. Opposite of 30 is 1. Opposite of 60 is the square root of 3. And we know the hypotenuse to be the largest value 2. So tangent of 60 degrees would be defined as opposite square root of 3 over adjacent, which is 1. I'd like you to study and probably take some good notes on page 275. In the middle of the page it says sines, cosines, and tangents of special angles. It goes on to give sine of 30, 45, and 60 in radians and in their coordinate values. The point it makes below the box is this. Note that the sine of 30 is equal to 1/2, which is equal to the cosine of 60. So these cofunctions, sine and cosine, because those are complementary angles, they have the same value. That is, theta is an acute angle, then the following relationship is true. Here we have an acute angle. The sine of 90 minus, not 30, 90 minus theta is equal to the cosine of theta. The cosine of 90 minus theta is equal to the sine of theta. And we can see that. in the same breath, these cofunctions, tangent and cotangent, the tangent of 90 minus theta is equal to cotangent theta. The cotangent of 90 minus theta is equal to the tangent of theta, and secant and cosecant follow. Let's look at example 4. Using our calculator to evaluate, this is example 4, using the calculator, evaluate the cosine of 5 degrees, 40 minutes, and 12 seconds. We talked Monday about putting that into your calculator. I want you to go ahead and enter that. Looking closely at example 4, converting the decimal to degree form, or the degree to decimal form. You also know in your apps that you can convert that quickly and easily. So go ahead and try example 4 and read through that, and then try problem 33. Come right back here and we'll look at it. In exercise 31 through 36, we're going to look at 33, and it says use your calculator to evaluate each function. Round your answers to 4 decimal places, and make sure that your calculator is in angle mode. We're going to look at 33. It says secant. Let's talk about the secant. The definition of secant is 1 over cosine. So we're going to evaluate it as such. Let's see if I can find my calculator again. So we want to evaluate 42 degrees, 12 minutes. 42, that's the easy part. We're going to go to the apps, right above apps. You can see we're using second angle. We're going to select that degree, 42 degrees, 12, back to the apps, to minutes, enter. And we can see we get this value. We can take that from here, 1 divided by the cosine of the answer should give us what we're looking for, 1.3499. So let's take a look at the second part of problem 33, which says that we want to find the cosecant of 48, this is going to go away here for a minute, cosecant of 48 degrees, 7 minutes. So if we bring that calculator back, we can plug in that value. Cosecant, let's find the cosecant, or let's find 48.7 degrees in decimal first. 48, 7 minutes. Again, we are in degree mode. In degree mode, we're going to hit enter and get our decimal representation. So problem 33 says we're finding the cosecant. Cosecant is the reciprocal of sine. So let's try this. Let's go reciprocal. Let's take that. Fraction, reciprocal, 1 over the sine. 1 over sine is cosecant of our previous answer. And that should give us the decimal value we're looking for, 1.3432. We're at the top of page 276 talking about the trigonometric identities, and we are going to spend a great deal of time next chapter when we're graphing. We're going to be learning these identities, and what I've been talking to you about is this, that sine and cosecant have an inverse relationship. Sine is equal to 1 over cosecant. So if we ever have values of sine or cosecant, we can quickly identify and evaluate the cousin value. Cosecant is 1 over sine. And each time I write these, I'm just being lazy, and there should be a theta in there. Cosine is related to secant. We just went over these. 1 over secant. And secant is 1 over cosine. tangent, obviously, tangent and cotangent go together. Tangent is 1 over cotangent, and cotangent is 1 over tangent. And these are all found in your textbook on page 276. But let's take a minute to look at the bottom of the fundamental trig identities. It's the Pythagorean identities at the bottom, and I specifically want to spend some time on this one, sine squared theta, which is also written sine theta squared. Those mean the same thing. So back to what we were doing. We'll go over more of that later. Sine squared theta plus cosine squared theta equals 1. So we know if we find one of these values, we can quickly and easily find the other. So let's look at this simple fact. Sine of theta in our unit circle is equal to the y value over the radius. Cosine of theta is equal to the x value over the radius. And we know in this unit circle, our radius, that circle doesn't start with an S, unit circle, our radius is 1. So we can look at writing this as sine squared plus cosine squared is simply this. We know our radius to be 1. Sine theta equals y, and so sine theta squared is simply y squared. Cosine theta equaling x, that's x over r. Our r value is just 1. So cosine theta would be x. Cosine squared theta is x squared. And we get our simple fact, x squared plus y squared, the equation of a circle with a radius of 1. I'd like to go to the second identity there. It says tangent squared theta plus 1 is equal to secant squared theta. Well, where does this idea come from? Let's go back to our original that we were just working with, and that was sine squared theta plus cosine squared theta is equal to 1. And what we want to see in proving this top identity are tangents and secants. Understanding that, we could probably see that the cosine value needed to go away. If we divided both sides, every term on both sides, by cosine squared, we start to see this idea of how we're going to be solving these mysterious little puzzles. I want you to think of tangent as opposite over adjacent, or y over x. And we know that y is sine, and we know that x is cosine. And we see that identity right here. So we can replace sine squared theta over cosine squared theta with tangent squared theta. Of course, cosine divided by itself is simply 1. And we know that 1 over cosine and secant are inverse properties. 1 over cosine squared is simply secant squared. So there's our second identity. The third one would look a lot like this, and we have to do it quickly because I'm running out of time. Sine squared theta plus cosine squared theta equals 1. We're going to get rid of our sines now because we've got cotangent squared theta plus 1 equaling cosecant squared theta. We're going to take out the sines. We're going to divide everything by sine squared theta and sine squared theta. And of course now you guys are thinking, okay, what are these identities? Sine squared over itself is 1. Cosine over sine is cotangent. It's the inverse of tangent. It's cotangent squared theta. And of course 1 over sine, that is our relationship cosecant squared theta.